Have you ever stopped to think about what's really running the show inside your computer or your phone? We're about to pull back the curtain on this unsung hero, probably the most important piece of software you use, and you might not even realize it. So let's get right into it.
Okay, so just think about what you're doing on your computer right now. You've probably got a web browser open, maybe some music is playing in the background, you might be typing in a document. But what's the one program that's actually the master of ceremonies here, the one doing all the heavy lifting behind the scenes?
Well, it's not any of those things. The answer is the operating system, the OS. And the best way to think about it is like a conductor of a huge, complex orchestra. See, the conductor doesn't actually play an instrument, but without them, all you've got is just a bunch of noise. The OS is what takes all that chaotic hardware and turns it into a perfectly coordinated symphony.
So here's what we're going to cover. First, we'll get to know our invisible conductor. Then, we'll see how it directs the hardware orchestra and juggles all your programs. After that, a quick look at its history, and we'll finish up by seeing just how the OS is absolutely everywhere today.
All right, let's kick things off with the most basic question. What is an operating system, really?
At its heart, the OS is basically a translator. You know, when you click your mouse or type on your keyboard, you're not talking directly to the metal and silicon inside the box. Nope, you're giving an instruction to the OS, and it's the OS's job to be that go-between. It takes your request and translates it into a language the hardware can actually understand. It handles all the messy, complicated stuff so you don't have to.
And that leads us to a slightly more official definition. The operating system is the program that manages all the computer's resources, the memory, the processor, everything. It's that critical bridge between you and the machine, the absolute foundation that every other app or program is built on top of.
And our conductor, the OS, really has three big jobs. Job number one, run your programs. Make the music actually play. Job number two, make the whole system easy and convenient for you to use. And number three, use all that hardware, the orchestra members, as efficiently as it possibly can. No wasted time, no one just sitting around doing nothing.
Okay, so let's dig into that a little deeper. How does the OS actually manage all the physical hardware? How does it conduct that orchestra? This orchestra metaphor works really well here. The CPU, the brain of the computer, is like this brilliant but super single-minded soloist. It can only focus on one thing at a time. The computer's memory, the RAM, that's the sheet music. It's where all the instructions are held. And then you have your keyboard, your mouse, your screen. Those are all the different instrument sections, all waiting for the conductor to give them their cue.
But that brings up a really good question, right? If the conductor is busy with the soloist, how does it know when, say, the keyboard section has something to say, like when you've just pressed a key? It can't be looking at every single musician all at once.
Well, the answer is this really clever system called an interrupt, and it's exactly like a musician raising their hand. A device, like your keyboard, sends a little signal, the interrupt. The CPU immediately pauses whatever it's doing. The OS, our conductor, steps in, figures out what the keyboard wants, and handles it. And as soon as that's done, the CPU gets right back to what it was doing before. It's this constant dance of signals and responses. That's why we say an OS is interrupt-driven.
Now, to make sure all this doesn't turn into total chaos, the OS has a special superpower. It's called dual mode operation. Here's how it works. All of your normal apps run in something called user mode, where they can't cause too much trouble. But the OS itself, it runs in a privileged kernel mode, where it has the keys to the entire kingdom. It's like the conductor is the only one allowed on the podium. A regular program can't just jump up there and start directing the orchestra. It has to ask the conductor, the OS, for permission.
All right, so that's how it manages the hardware. But what about all the software? This is where things get really, really interesting.
I mean, think about it. You can listen to music while you're writing an email, with notifications popping up from a chat app. It feels like magic, like it's all happening at the same time. But it's not magic, it's our conductor, the OS, just being an incredible juggler, switching between all those different tasks so fast that to you, it feels completely seamless.
And the OS uses two main tricks to pull this off. The first is called multi-programming. Its main goal is just pure efficiency, making sure the CPU, our soloist, is never idle. There's always another job ready to go. The second trick, which is what we're all used to, is multitasking. This is all about making the computer feel responsive to you. The OS switches between your programs so ridiculously fast, we're talking fractions of a second, that it creates this perfect illusion that they're all running simultaneously.
Of course, this amazing juggling ability didn't just pop up out of nowhere. It took decades to get here. So let's do a quick trip back in time and see how it all evolved.
Way back in the beginning, in the 50s, you had what were called batch systems. These computers could only do one thing at a time, a total solo recital. Then in the 60s, a huge breakthrough, time sharing. Suddenly, multiple people could use the same giant computer at once, kind of like a shared practice room. Fast forward to the 80s, and boom, the personal computer arrives. Now everyone gets their own orchestra at home, with OSs like MS-DOS and the first Mac OS. And that brings us to today, where we have these insanely powerful orchestras right in our pockets, iOS, Android, all connected to this massive global network we call the cloud.
And that brings us right up to today, where the operating system is, well, it's everywhere.
And it's not just one size fits all. There's a whole zoo of different operating systems out there now. You've got the ones for big mainframe computers and servers, the ones on our laptops and phones, of course, but then there are these tiny, stripped-down, embedded operating systems running inside your car, your TV, even your microwave. And get this, they're also real-time operating systems. These are for things like airplane controls or medical equipment, where even a tiny delay could be disastrous. So yeah, they really are in everything.
One of the most mind-bendingly powerful ideas in modern computing is something called virtualization. The best way to picture it is having a master conductor, that's the host OS, who is so good they can manage a bunch of other guest conductors, each with their own mini orchestra, all on the same stage. So one single physical computer can act like it's dozens or even hundreds of separate computers.
And this isn't just some cool party trick. This is the engine that powers the entire cloud. It's what allows a single giant server in a data center to pretend to be hundreds of smaller servers for hundreds of different customers. So, anytime you use a cloud service like Netflix or Spotify, you're almost certainly using what's called a virtual machine, one of millions of those little guest orchestras being conducted inside a gigantic warehouse full of computers.
So when you strip it all the way, you get back to this one fundamental truth. At the very core of the operating system is a piece of code called the kernel. And that kernel is the one program that is running without fail at all times on your computer, from the second you power it on to the second you shut it down. It is the always-on, ever-present conductor.
So there you have it. The OS is our digital conductor, translating our wishes and directing the whole show. But here's a final thought to leave you with. As AI gets smarter and smarter, well, right now the OS just conducts the music that we write for it. What happens when it starts composing the music itself? A pretty wild thought, isn't it?